Hello everyone, I'm Kailash Prasad, PhD scholar from Nano Electronic Device and Circuit Lab, IIT Gandhinagar. Welcome to live session 11 uh, on design and analysis of VLSI subsystem. The course has been taught by Professor Madhav Rao, and we have this session every Tuesday from 7 p.m. to 9 p.m. I'm extremely sorry I couldn't take the last session, but now I can. Will be actually I have already been discussing about all the concepts regarding the VLSI design, and we have done all the questions from week 1 to week 12. This session is mostly session where I would like to summarize whatever we have been discussing over past say 2-3 months. And what we have done, we have started with in the very first week CMOS transistor and current model. Then we have seen the CMOS inverter and the characteristics, noise margin, delay of the inverter, and the RC delay, followed by delay optimization, combinational circuit. Then we have went to the back end of the design, where we have been discussing about the stick diagram and the interconnects. Then we have been discussing about power, the static power, and the CMOS latch and flip-flop design. Further, we have been discussing about static timing analysis. In the last lecture, we have gone into a very greater detail. So, what I will do today is I will just go back again to my various first lecture and like to summarize what is the motivation behind the VLSI design. We have been seeing the advancement of AI, 6G, Internet of Things, 5G, the data center, and the self-driving car. And the underlying thing in all this architecture is what we call as the chip, right? And the idea over last few weeks or the entire 12 weeks was to understand the concept behind designing these chips, right? So the basic concepts remain the same, right? You need to understand, okay, how to go ahead and design complex chip. And this was the history we have already been seen in the very first lecture. I will just quickly summarize what we have done. We have started with very one transistor, and then we have been to billion and billion of transistor, right? So the quite an advancement in the VLSI design. So you need to appreciate, right, the advancement that has been done in last 50 to 60 years is tremendous. Everything has grown exponentially. The performance, the throughput, and the capability of doing large things. This was a brief history of IC design, where we started with RAM, PROM, SRAM, then we have to DRAM, and we are with the very advanced memories like flash memory. Currently, we are talking about the memories like RRAMs, DRAMs, NMRAM, MRAMs, and other memory technologies. If we see some of the recent ICs, the Intel Nirvana, NVIDIA P100, there are AMD Ryzen's and all. What I would like to discuss over here is the top companies which you should focus on, or these are top of the semiconductor manufacturing company in the United States. And there are these design houses in India also, right? And suppose if you want to get into any one of this in these companies, what you have to do is you have to do a couple of things, right? The first thing is you have to understand what your role you are applying. Irrespective of the role what you are applying, you have to actually see what companies you're looking for. And the thing over here is these are the top 10 semiconductor companies. And if you are applying for say a processor design job, if you are applying for a memory design job, it doesn't matter. The basic concepts of the VLSI remains the same, right? So you have to understand the concept we have behind the VLSI. Then you have to get hands to the tool that has been used, that is actually being used in VLSI, like the Cadence, the Synopsys tools for designing custom chips. Further, if you are actually looking for companies where we design FPGAs and all, right? So there, what you do, you go through the entire FPGA flow, and yeah, that's what you have to do, right? There are two flows where one is the FPGA flow, where you design a chip in the RTL on the Verilog and you go through the entire flow, right? And you have an FPGA where you can demonstrate the things. The other flow is an moreover an ASIC flow, where you design an RTL design, but what you do, you go through the ASIC flow, you do the synthesis using some of the Cadence or Synopsys tool, then you do the placement and routing, we design a chip, then you send the chip to the foundry, right? And then you get the final chip. So irrespective of the flow and all, the basic first step there is the design using Verilog. What we have learned over here, right, that can be also designed using the custom flow. In the custom flow, what you have to do is you have to take the transistor and you'd have to design the chip using the transistor level design. These designs we do in the Cadence and all, right? There are some of the companies which are there in India. All the semiconductor companies are available in India, right? And this is a very right time to get into the semiconductor domain, I must say, right? And you should get all the skills to get into the semiconductor domain. And please note that the designing of this kind of chip now also, actually it requires the proprietary software, but even without proprietary software, what you can do is we can design the chips using open source softwares. Okay, so these are some of the top EDA companies which are available, from Xilinx, Cadence, Synopsys, Keysight, Ansys, and the Metro Graphics, right? Most of these tools which you'll be using in the VLSI design will be from either one of these top EDA companies, right? And there's a huge plethora of companies which I've been showing over here. Uh, this I have already shown that we have a huge push from the government in the semiconductor domain from last few years, right? And if you want to get into, this is the right time, right? What I want to discuss in a greater detail, not in a much detail, right, was is the IC design flow. The IC design flow is the process of developing an IC to the point at which the IC can be manufactured in a semiconductor fabrication plant, right? And this involves the use of sophisticated devices and the process models and the mathematical tools and the software to capture, simulate, and optimize and detect errors during the process. And what we have learned in this tutorial series and in this course was the digital IC design. There are analog, RF, and mixed signal IC design is there, right? And you can do wonderful courses over NPTEL to understand the basics of that. Now, IC design flow is different for each foundry, process, company, design groups, and even individuals. Okay, so you can have different flows for different companies. This is how a digital IC design flow looks like. What we do, we start with specification, then architecture design, the RTL coding, logic synthesis, logic verification and testing, then physical design, physical verification, fabrication, packaging and testing, and then you design the chip, right? What you do is you start with the basic Verilog, then you have a synthesis tool where you convert this Verilog into what we call as standard cells, right? The standard cells are the basic building block of you can say the digital IC design, right? This can be an AND gate, OR gate, or AOI gate, whatever gates you have learned over the VLSI design course, right? These all are made by the foundry. You can also make them and have the basic design, right? And yeah, this is I have actually taken from my lectures from IIT, right? So that's the reason it is written as a course plan. Rather, what I wanted to show you that after, what is the next step, right? You have learned the VLSI design. Now what you have to do, so you have to go through the digital IC design, right, where you have to start with say Verilog or the system Verilog, and you get an expert in this tool to design complex hardwares. Then you have to learn about logic synthesis. You have to use tools. There are various open source tools which are available for logic synthesis. Then there are tools for logic equivalence check, right? So whatever you have synthesized, right, and whatever you had designed, it should be actually same, right? So there are tools for that. One of the key concept which we have learned was the static timing analysis, and you have to understand that whatever you are designing, that should follow the timing constraints, right? There should not be any timing failure. Once you ensure all of this thing, you go to the back end of the design where you do, so you have designed say some cells like AND gate, OR gates, or whatever you have designed. You have to actually make layout of it, and you have to place each of them, and you have to connect them, right? So this comes under placement and routing. Further, what you have to do is you have to provide the clock to all the flip flops or whatever the sequential logic you have. Okay, so that comes into the clock tree synthesis. And the final, you have to do the packaging, and you have to connect the IO pins. What kind of tool do you use? Do you use tools from different vendors like Cadence, Synopsys, and Mentor Graphics, and Xilinx, right? I have listed down these tools, but what you can do, you can actually go ahead with these tools and all. Okay, so how many students have joined over here, right? So, okay, yeah. So I think, yeah, there are four students, right? So I couldn't take the last session because I was abroad. I still am abroad over here, but yeah. So if you guys have any questions regarding, okay, so what are the next things to do and all, right? This is the right platform to ask. I will have a detailed session the next week regarding the same. But if you have any doubts regarding whatever the things we have done in the courses or anything, yeah, this is the right time to ask for you. Ram and Bhavna, I think there are only two students who have joined this session.
Hi,
Yeah.
yeah, hi, sir. Sir, as I said earlier, I'm from different stream, right? So how I can focus on the things right now?
Okay, so
I'm
what
learning on
stream
design and
you are? What
verification.
stream you are?
I'm from cybersecurity.
Okay, you are a
I'm from
computer science engineer,
cybersecurity
right?
and
Okay, so
computer science
are
engineer.
you are
I'm
you in
interested
the
in this, and I.
are you in the group which I have created in the WhatsApp group, Ram?
Yes, sir. Yes.
Okay. So, see, what I can do is I can
Yes, I
share.
am there.
Yeah, I have actually already shared a list of lecture that was a part of my LinkedIn post, right? So what you have to do is you have done the VLSI design. I was discussing that. Okay, what you can do is you can do the digital IC design, right? And once you are good at the IC design concept, because IC design is a very huge thing, right? So you have to start with the RTL to the RTL, where you learn the Verilog, the system Verilog, or any of the hardware description language, and then you take the design to make the final layout, right, with the entire digital flow. At each and every step, you have to understand, okay, how things are going, and you have to apply the concepts whatever you have learned in the VLSI design at each and every step. Okay, so I can share you the list of the lectures which are available in the NPTEL. So I will reshare my post in the WhatsApp group. Yeah, I will just come with the second part. Okay, just
Mhm.
1 minute. I think what you can do. I'm just opening my LinkedIn over here. I will just Yeah, sorry. Yeah, I am just opening my profile, and this will actually answer both of your questions. One was, okay, what kind of courses you need to do, and I'm extremely sorry. Yeah, okay. So yeah, yes. So I have this post, right, where I have actually shared the list of the courses, right from the digital circuit to hardware modeling. Then you can see the semiconductor device and circuit, analog electronics, then fundamental of microfabrication, and this is the list, this course, right, which we are actually doing. Then the physical design, And there is one wonderful course of digital VLSI design from Adam Teman, right? And then the digital IC design. Right. So there are this course is in great sequence, right? What you can do, you can start with this digital IC design course from Professor Janki Raman, and then you do this course from Professor Adam Teman, right? Once you do this course, actually you will have a very good understanding of VLSI design and the RTL TTDS design, right? So that will be the first part. That's the theoretical aspect of it. Okay. And you can actually do all the
Okay.
courses because you are from another domain, right? So you need to understand the concept behind that. The second thing is, okay, what kind of tool do you use for, say, doing these designs, right? And there are actually some of the open source tool chains which are available: Open Road, Hammer VLSI, Qflow, and RAM. And one is from the Kunal Ghosh, right? He is I think the founder of BSD, VLSI System to Design, right? You can use this tool, right? You design a code in Verilog, or you design the custom design, and you can pass through the entire flow. What kind of PDK? Some of the open source PDKs are also available. You can go to this my you go to my LinkedIn profile, and you can find out of this post, and you can start designing the things, right? So whatever you have done till now, you have to actually convert into design, and you can have an hands-on experience, right? Once you have that, then you can apply for the companies, whatever you are aspiring for. Does that answer your question, Bhavna?
Okay. Okay. Thanks.
So when is your exam, the NPTEL exam?
29th, we got
Nine.
hall
Okay,
tickets
before
yesterday
that, we
only,
will have
29th.
another session, I guess, right? So I can summarize everything I have done, and maybe I can also, whatever post I have shown, I will go in a greater detail, right? So this can be helpful to you guys, right? How to get ahead in the career in the VLSI domain, right? Do you guys have any questions of whatever we have done as of now?
So those LinkedIn posts are regarding to NPTEL or
Yeah,
the
these are
links?
NPTEL posts, and there are some lectures from
Okay,
Coursera
fine.
also.
We'll
Okay,
just
these are free, right? You can go in YouTube, you can learn, right?
okay.
Learning now is free. The only thing is you have
Mm,
to
yes.
have this the motivation behind learning the same. And anytime if you feel that okay, you might need some expertise or expertomy opinion, or you need any kind of guidance, you can directly connect with me with the LinkedIn, or you can mail me, right, in the email ID. Okay.
Sure, sir.
Okay, so yeah, it was, I think it is a very short session then. I was expecting that, okay, more people will join and more questions will be there. What I can do, I can have a follow-up video I will record, and I will just share it with you guys. I will just club this video with that together with some more information in okay, how to uh, or what kind of courses, or what are the list of the courses over there, right? I think that will help you guys to go ahead.
Yeah, thank you so much.
Okay. Can I share the WhatsApp group link? I'm not sure. So yeah, this is the link. Copy link URL. Okay. I hope you'll be able to join using this link. Okay, then uh, we will connect you in the next session. Please join that session. That will be extremely helpful for you. For if you want to have any career in VLSI design. Okay, so I will be discussing in a very greater detail that okay, what kind of opportunities you have, right? What kind of positions are there? Where do you apply, and all sorts of things. I'll be discussing over there. Okay, so thank you for joining. Yeah, so it was a very short session in that regards. Okay, thank you.